Okay, it looks like you guys are ready for 4.2, day 3. So on this worksheet, the first question says, find the missing sides in each triangle. All right, well, in this triangle right here, that's a 30, 60, 90 triangle. I know that one. So that one's not going to be hard at all because I know that it's a 30, 60, 90 triangle. So if I go back to what I know about a 30, 60, 90, I'm going to draw my 30, 60, 90 in the same way that I usually, that this one's set up. Okay, so it's 60, 30, and this is where the right angle is. And you need to have this memorized, that across from the 30 is where the 1 goes. And on the hypotenuse, that's where the 2 goes. And the other side is the square root of 3. Okay? Now, I'm showing you how to do this without a calculator, and because that's how I'm assuming they're going to want us to do this. But if we could use a calculator, which actually I think some of these later ones, I'll show you how to use a calculator. If we could use a calculator, it'd be even easier. All right, so now with the 30, 60, 90 triangle, I know it's 1, 2, and the square root of 3. Well, in this case, look where the 60 is, and look where the 14 is. The 14 should be a 2 if it was like this. All right, so if I'm going to use these ratios, I can say that, see the 2 compared to the 1? Do you get that the 14 compared to this side down here? That side down there must be a 7 to keep that same ratio going. Okay, and then this side over here, this is a 1 to the square root of 3 ratio. Okay, just think of this as having a 1 times the square root of 3 in front of it, and a 1 times the 2 in front of it. Okay, that'll help you to see that this side here must be 7 times the square root of 3. All right, because this one, you take whatever's down here and you multiply it by the square root of 3 to get that side. And so since there's a 7 down here, I'm going to go 7 times the square root of 3. All right, now, I don't know if you followed that way. Let me show you how you would do it with a calculator. With a calculator, you could say to yourself, okay, I need to find this side, let's say right here, and let's call it A, and let's call this side B. You could call it anything, but since they're the legs in a right triangle, it makes some sense to do it this way. All right, so if I was going to try to find A, I could use sine, cosine, or tangent to do it. So what do I really have here? Do I have opposite and hypotenuse? No. I have adjacent and hypotenuse. And which of the SOHCAHTOA involves an adjacent and hypotenuse? That guy does. So I should use cosine. All right, so I'm going to use cosine of, and what's my angle? 60. Cosine of 60 is equal to adjacent over hypotenuse, right? Ka. So what's the adjacent side? The side I don't know right here. A. Over the hypotenuse side, 14. Let me get rid of my little helper things, the A and the H there. So now I've got A over 14. Now if I just knew what cosine of 60 was, then I could continue with this problem, and maybe I should just type in cosine 60 on my calculator. Again, at this moment, if you didn't know what the cosine of 60 was, and you had no calculator option, you could go off to the side of your paper and say, 30, 60, 90 triangle, 30, 60, 90. This is 1, this is 2, this is square root of 3, and what is the cosine of 60? Here's 60. What's the cosine of 60? Cosine is adjacent over hypotenuse. It would be 1 over 2. Okay, so this is 1/2. Now if I go type it in on my calculator, I type in cosine 60, take a wild guess what you're going to get. Cosine 60 equals 0.5. Sweet. All right, so it's equal to A over 14. So all I did was replace this with a 1/2. And now, just to get A alone, I multiply both sides by 14. 1/2 times 14 would be 7 equals A. Now, I did that one pretty quick before because I knew that this side was the long side, that side was the short side, and so it had to be half as big. So if you like that logic way to do it, that's great too. All right, let's look at this. Let's skip to number 3 and look at that 30, 60, 90 triangle there. How do I know it's 30, 60, 90? Because it's got a 60. And that means this has to be a 30. All right, and do I know the side ratios there? Yeah, this one's a small side here of 1. This is like 2, and this is like the square root of 3. But wait a minute, it's like 5 square roots of 3? That means it's 5 times bigger than the normal one. So you can times this by 5 and times this by 5, and that means this side must be 10 and this side must be 5. Now, if that logic didn't work for you, I know my 30, 60, 90s really well, and hopefully you will later too. But if that doesn't work for you, then think of it this way. What do I have and what do I need? Let's say I want to figure out that side right there. All right. If I want to figure out that side right there, do I use sine, cosine, or tangent? Well, sine is the opposite over the hypotenuse. That would be this over this. That doesn't help me. So I'm not using sine. How about cosine? Cosine is adjacent over hypotenuse. That doesn't help me either because I don't have either of those two. So what do I need? I need the one that uses opposite and this side here, adjacent. Which one uses opposite and adjacent? If I look back at SOHCAHTOA, opposite and adjacent is tangent. Tangent of 60 is equal to opposite over adjacent. Opposite would be 5 root 3 over adjacent would be, let me think, adjacent, I don't know what it is. It's right here. It's A. All right, so then, again, if you were forced to, because you had no calculator, figure out what tangent of 60 is, go off and draw a 30, 60, 90 triangle. 30, 60, 90. This is 1. This is 2, and this is square root of 3. And if I want a tangent of that, tangent is opposite over adjacent. That'd be this over this. Tangent of 60. Opposite over adjacent. Make sure I got that right. Opposite over adjacent. Yep. Square root of 3. So this is the square root of 3 over 1, which is the square root of 3. Equals 5 root 3 over A. And then I just have to get the A alone. Okay, so I'm going to multiply both sides by A. So it'll be A root 3 equals 5 root 3, because then the A's on that side cancel. And then I divide both sides by root 3. And I get A equals 5 root 3 divided by root 3. And then those cancel, so A must equal 5. Whew. Now, got it faster the other way using logic. But if nothing else, you need to be able to set up one of these and use a calculator to do it. All right, let's try one more. Let's look at number 4 together quick. On number 4, I'm just going to help you set it up. This time I promise I'm not going to solve the whole thing. That looks like it's 30 degrees. So I'm going to say, if I want to solve for that side there, for instance, I could solve for the other one if you'd rather. Maybe we should solve for C this time. Let's do that. All right, so if I'm going to use 30 degrees here, I'm sure to use sine, cosine, or tangent. Well, this time I have opposite and hypotenuse, so I should use sine. Sine of 30 is equal to the opposite, which is 173, over the hypotenuse, which I don't know. There we go. And then if I type in sine of 30 on my calculator, I get 1/2. And I just have that one memorized, so I know it's going to be 1/2. If I didn't have it memorized, I go off to the side, do my 30, 60, 90, 1, 2, square root of 3. What's the sine of 30? Sine is opposite over hypotenuse, 1 over 2. Is equal to 173 over C, and then you just solve for C. Okay, that's how you start. How about this, when they get to number like 10 and 11? Solve for the variable in each of these equilateral triangles. All right, 45, 45, that's an easy one. That means this must be the same as this, because it's a 45, 45, 90 triangle. I'm going to draw you one just to prove I know what's going on here. This is a 45, this is a 45, this will be 1, 1, and the square root of 2. See how these got to be equal to each other? And think about this as a 1 times the square root of 2. So do you get, this one here is 8 times bigger than kind of my standard triangle. So it's 8 times bigger than this side, and it's 8 times bigger than that side, which would be 8 root 2. So by my knowledge of 45, 45, 90s, I can do that. Now again, if you're weak on that, then you have to go back to this and say, all right, to figure out x, I'm going to go, sine is opposite over hypotenuse. So if I use this angle right here, I could use sine of 45 is equal to opposite over hypotenuse, which would be 8 over x. And then on my calculator, I'd figure out what sine of 45 is. I go over and type in sine 45, and I get 0.707 equals 8 over x, and then I solve for x from there. Okay? But since it's a 45, 45, on the tests, you're going to be expected to do this part without a calculator. So let's look at this next one and say, how could we do this without a calculator? This is one of the trickier kinds. Now, do you get that this side here and this side here, these two sides have to be the same as each other. And the ratios you would normally have, if I draw this in the same orientation as I see it up there, this would be 1, 1, and the square root of 2. This side here is not the square root of 2. It should be the square root of 2. So if you take this side right here would have to be, this is a tricky one for a lot of people to see, it would have to be the square root of 2 divided by 8. All right. I'm not even positive I'm doing that one right. So instead, I'm going to set up my kind of classic trig and say, okay, do I use sine, cosine, or tangent? I'm going to use this angle right here, and I want to use this and this, so that's opposite and hypotenuse. So sine of 45 is equal to opposite over hypotenuse. Opposite is y over the hypotenuse is 8. And how did that help me? Just because now, if I can just figure out sine of 45, it'll be easy. I'll just have a number there, and I'll just multiply both sides by 8. What is the sine of 45? Well, I go over to the side, draw my classic 45, 45, 90 triangle, 45, 45, and 90, and that's see, these are both 1s, and that's the square root of 2. And then if I want sine of 45, I can use that one. Either one would work. Sine is opposite over hypotenuse, 1 over square root of 2. Okay, and so this would be, sine of 45 would be 1 over the square root of 2 is equal to y over 8. And then this is a classic case where cross multiplying could work, but I guess I'd just multiply by 8 because I just have the y almost alone now. So times by 8, and these 8 would cancel, and I get y equals 8 over root 2. I hope that's what I said before. Maybe I said square root of 2 over 8, which would be a very easy mistake to make. All right, so final answer, y equals 8 over the square root of 2. If I use the calculator for it, type in sine of 45, it's not going to give me something nice like 1 over the square root of 2. But when I type in sine of 45, I get 0.707 again. And again, I could use that right here if I just wanted to go the decimal way and say 0.707 equals y over 8 times both sides by 8. You'll have your answer as a decimal. But you do need to know how to do this for tests with the 45, 45, 90 triangle. So as soon as you see something like this, sine of 45, oh, I can do that one with the 45, 45, 90 triangle. 1, 1, square root of 2. It's like magic. Sine of 45, opposite over hypotenuse, 1 over the square root of 2. 1 over square root of 2 is what 0.707 is. All right, one more, and I think, nope, one more after that. Okay, so in this little section, we have problem 14. Solve for the variable in each of these equilateral triangles. All right, so if I'm going to use this a right here, I'm going to, okay, I'm thinking quickly for a second here. Oh, I can tell what kind of triangle this is. Is it a 45, 45, 90 or a 30, 60, 90? Well, when you have an equilateral triangle, it's got 60-degree angles in the corners. Did you know that? I know that. I hope you will remember that. So if there's 60-degree angles in the corners, then this little angle right there, that's a 60. This angle right there would not be a 60. It'd be half of 60, right? So then that would be a 30. So what we really have right here is a little 30, 60, 90 triangle where this side's 2, because, you know, this 4 was for the whole thing. So just this half would be 2. And this is A, and then there's a 60. So now I can set up my little 30, 60, 90 deal. And I'm going to say, should I use sine of 60? Let's see, I have the opposite and then I have the adjacent. I should use the tangent of 60 because that we use the opposite and the adjacent sides. And that would be A over 2. And what is tangent of 60? And again, you can go off to the side, draw your little 30, 60, 90 triangle. Here's a 30, here's a 60, here's the 90, here's 1, 2, square root of 3. Tangent of 60, tangent is opposite over adjacent. That would be this over this, which is the square root of 3. All right, so then I can replace this right here with the square root of 3. So now I have the square root of 3 equals A over 2. And then you can multiply both sides by 2. 2 root 3 is equal to A. And there we go, 2 root 3. Okay, This one, they want b this time. You use the same idea, and you say, all right, I got a 30, 60, 90. This is a 60. That's a 30. And this side's 21. Okay, so you set up your little deal, and maybe you use 60, and you say, oh, I've got the opposite and hypotenuse. I can use sine. Of what degree? 60 is the opposite, which is 21. Over the adjacent, or no, see, sine is opposite over hypotenuse is b, and then I would figure out what sine of 60 is, put it here, and solve it. All right, last one I want to talk about is number 17. If BC is equal to 60, so basically they're saying right here, this side is 60, then AC would be what? And basically they want you to figure out this. I'm going to call it A. What kind of a triangle did they give me? This is a weird one. They gave me a 45 here and a 30 there. Well, this one is not 90, that's for sure. Okay, so let's see, that's 75 total for these two. It has to add up to 180. That'd be 105 degrees for that angle right there. All right. I am not exactly sure, to be totally honest. I'm going to pause for a second and figure this out. Okay, I think I figured out that this is a problem where using the law of sines would be really handy. And if you haven't already been taking notes, I would strongly recommend that you write this one down. Sine A over A is equal to sine B over B is equal to sine C over little c. And what on earth does that have to do with anything? Well, when you are doing a problem like this and the angles don't add up nicely so that you have a right triangle, if you have something other than a right triangle like this one where it's 105 and 45 and 30, okay, then you have to use this rule to be able to solve your problem. And sine A, well, I don't even see an A in here. Oh, yes, I do. Here's A, okay. Sine of that angle would be the angle across from it is like little a. Let me make sure you understand what I'm saying here. Okay, if you draw a triangle with just an A, B, and C, here, here, and here, let's say this is an A, and this is a B, and this is a C, then the little c would be across from the big C, that's the angle, okay? And the big B, of course, has a little b across from it here, and the A has a little a across from it there, okay? And so what we're saying is if we take the sine of this, it'll divided by this, that'll equal the sine of B, which is this one, divided by this one, and that will equal the sine of C, which is this one, divided by the one across from that. All right, so let's try to use that rule on the problem that we have, okay? So if we say sine of A, let's stick with this being A right here since we've got an A right there. Okay, sine of A over A. Well, that's like saying sine of 45. So for our problem, I'm going to write this up. Sine of 45, because A is 45. Over the side across from that is A. This one right here, right there, that's supposed to be A. So that's 60 is equal to the sine of B. We know that. Sine of B and the sine of B. B is 30, see? Sine of 30 over, that's one we don't know, so we put an A. Okay, do you see how now I have an equation where I can figure out everything except A? I can go in my calculator and figure out what sine of 45 is, or I can go off to the side and figure out what sine of 45 is using a 45, 45, 90 triangle. And sine of 30, I can use a calculator and figure it out. Turns out to be a half. It's a good one to memorize because it comes up a lot. Or you could go off to the side and figure out what the sine of 30 is using a 30, 60, 90 triangle. Okay? So I'm going to erase this part to give me some room to write, and I'm going to figure out what the sine of 45 is by using a 45, 45, 90 triangle. You're going to be drawing these things in your sleep if you're going to pass this class. 1, 1, square root of 2. Okay, and so if I have sine of 45, sine is, like, let's pick that 45. Sine is opposite over hypotenuse, 1 over the square root of 2. So for this top part here, sine of 45, I can put 1 over the square root of 2. 1 over the square root of 2 over 60 is equal to sine of 30. I got to draw a 30, 60, 90 triangle to get that one. Actually, that's pretty bad, 30, 60, 90. I'm going to try that again. 30, 60, 90. This is 1, this is 2, this is square root of 3. Okay, and I need the sine of 30. Sine of 30. Opposite over hypotenuse, 1 over 2. I knew that one was a half. That goes with that before. All over A. Do you see how now I can just cross multiply to solve that one? Get A alone. All right, so I'm going to just take A times... Sorry. Okay, so it's A times the 1 over root 2 is equal to 60 times a half, and 60 times a half is 30, and then I basically got A over square root of 2 is equal to 30, and then I'll multiply both sides by the square root of 2. A is equal to 30 root 2. Okay, so law of sines, really handy. It's pretty easy if you just remember it. Sine of A over the leg, sine of B over little b, equals sine of C over, let's see, and that triangle that goes with it looks like this. This is A and B and C, and it won't be a right triangle, even though it kind of looks like it is, because if it was a right triangle, we wouldn't have to use this. And then the little b is across from the b, the little c is across from the c, and across from the a here is the little a, and that's how they're all set up. All right, I hope that's handy to know. Have a great day. I should see you soon.